Okay, so what we're going to do today is we are going to work on writing multi-step equations. And today's the 10th. Okay, writing multi-step equations. So our first example. Is a whole number has the property that when the square of half the number is subtracted from 5 times the number we get the number itself. Okay. So again, if we were in person, I would get to hand you a worksheet. So I'm sorry for the writing today. We'll survive it though. There's lots going on here. So we're going to go back to the start of this and we're going to take a look and figure out how we're going to represent these words. So a whole number has the property that when. So far, none of that is really necessary for writing our equation. So we're looking at the next part, the square of half the number. The square of half the number. So right here, the square of half the number. Okay, I'm kind of like boxing this in blue. So when I say the square of half the number, how could I represent this? There's two possible ways. Does anybody know one of the ways? You can just come off mute and tell me. Okay, we're not sure. That's okay. So look, if I have half the number, do I know what the number is? No, right? It's my unknown. So I represent that with a variable. I'm going to use x because that's our most common one, right? Of half the number. So I need half of this x. One of the ways to show half is to divide by 2. Another way to show half would be to have a half and multiply it with x. So both of these are half the number. But it's saying that I need to square half the number. So this has to happen first. I have to get half the number first. And then my next step would be to square it. So in order to make sure I do something first, what needs to go around this part of the problem?
Parentheses.
Yes, parentheses. Parentheses always say do me first. So this is like I got to do this first in order to then square it. So this is the part that matches the blue. Now, what we're going to do is we are going to look at the next portion. So I'm going to reread from the start again. A whole number has the property that when the square of half the number is subtracted from, so is subtracted from 5 times the number. Is subtracted from 5 times the number. So it's telling me that this is being taken away from 5 times the number. So is it okay to put 5W here? I'm seeing people shaking their heads no. Okay. Why is it not okay for me to put 5W? I don't know the number. Just come off of mute. Yes, sir. Okay, everyone's going to be shy. It's not okay to have 5W because all of this is about the same number that's unknown. So because it's all about the same unknown number, I have to represent it with the same variable. So this is 5 times a number, the same number, and then we're subtracting the half of that number squared. Oop, I left out an X. There we go. So the square of half the number, that's here, is subtracted, so it's being taken away from 5 times the number. And then it says we get, hold on. This is 5 times the number. And then it's telling me we get the number itself. So at the end, it should equal the number itself, which is X. So either one of these would be appropriate for how we would represent this multi-step equation. Do I have a question? Not seeing any. If you have one, just come off of mute and ask. Otherwise, here is example 2. Okay, in example 2, we have Paolo has a certain amount of money. If he spends $6, then he has 1/4 of the original amount left. Sorry, my 4th got kind of big and it's all crazy off, hard to read. So there we go. Okay. So in this problem, I need to define my variable. I'm going to, again, just use X because it's the most common and whatever. I have no other reason. So X equals, I'm defining my variable. What is X going to represent? Paolo has a certain amount of money. Do we know how much money he has?
No.
No. So that's what my variable is going to represent. The money Paolo has. Okay. So then what's going to take place is we are going to read the next sentence. If he spends $6, okay? So Paolo has money. Here's Paolo's money. He spends $6. So is he gaining money or losing money?
He's losing money.
He's losing money. So we're going to represent that with what?
Subtraction.
Subtraction. So this is now I guess I'll do it in pencil, minus $6 because he gave those $6 to someone else, right? He no longer has them. Hopefully he spent it on something good, right? Like a boba tea or I don't know what. Okay. Next part. Then he has. So after this, then he has 1/4 of the original amount left. 1/4 the original amount left. So he has 1/4. And what was the original amount again?
X.
X, right? We don't know. So he has 1/4 the original amount left. Questions about this one? Okay, here's our next one. Okay, my next one, example 3. When a fraction of 57 is taken away from 57, what remains exceeds 2/3 of 57 by 4. There we go. So again, example 3, when a fraction of 57 is taken away from 57, what remains exceeds 2/3 of 57 by 4? So many words, right? So the first thing we need to do is identify what it is that we're solving for. And our unknown right now is going to be a fraction of 57 because I don't know how much that is, but I know it's going to be a piece of 57, part of 57. So this is a fraction of 57. Okay. And then we're going to go back and we are going to start to piece together what this all means. So when I look at my sentence here, it says, when a fraction of 57 is taken away from 57. So when a fraction of 57 is taken away from 57. So I have to start with 57 and I'm taking away a fraction of it. Because we determined that our variable is a fraction of it. This is my purple. What remains? So that's going to be my equals. Now there's this word here. What remains exceeds? So what do we think this means? What remains exceeds 2/3 of 57 by 4. So this exceeds here is kind of signaling our equals. Okay, but it's saying that when a fraction of 57 is taken away from 57, what remains, so the whatever this equals, exceeds, so it's going to be bigger than, but equal to, 2/3 of 57 by 4. So 2/3 of 57. How do I show that? What's happening there? Multiply 2/3 of 57 by 4. So it exceeds 2/3 of 57. So what does that mean? It's larger than 2/3 of 57. And how much is it larger than?
4.
By 4. So that means that I need to do what with that 4?
You add the 4.
I got to add the 4, right? By 4. There you have it. Okay, I'm going to do one more example because this is the one that typically gets everybody confused. And then we're going to go on with some other stuff. So, example 4. The sum of 3 consecutive integers is 372. Okay. So first thing I need to do is define my variable. Again, I'm going to choose x. Sorry. So what is x going to represent here? Okay, let me ask you this. Do we know what the integer is?
No.
Head nods no. So if we don't know what the integer is, then x has to represent that. Okay, so x is going to be, I'm going to put my first integer. Okay, x is representing my first integer. The sum. What does sum mean?
Add.
Adding. Okay, so, oh, that's probably not the pen I wanted. Let's try this pen. The sum, right? This means add of 3 consecutive. 3 consecutive. Does anyone know what that means?
3 numbers that are together, like 1, 2, and 3.
Great. So 3 numbers in a row. 3 numbers in a row. The sum of 3 consecutive integers is 372. So the sum, so I'm going to need to add 3 numbers in a row that are integers, and that's going to, what does the is mean? Go ahead, just come off mute.
Is it equal to?
Equals to.
Equals. And that's going to equal 372. Okay? So here we go. If my x, which is my variable, represents my first integer, here's number 1. Okay? Sum, adding, number 1 plus. How am I going to represent the next integer in a row?
X plus 1.
Okay? X plus 1. Right? Because if this was 1, let's pretend this was 1, and then the next number would be 2, right? So when we go in order, counting order, each number is growing by how much?
1.
1, okay? So here's number 1, here's number 2, and then I need a third one because I need 3 numbers in a row.
Plus 4.
So x plus. Now, from here to here was x plus 1, but now I have to move again. So it can't be x plus 1 because this is 1 more than this. So this has to be what?
2. X plus 2.
X plus 2. And then is, which means equals 372. And there you have it. That is writing multi-step equations, everybody.